We need to show the derivative of y with respect to x is given by this particular expression whenever we have y is given by this particular function. So let's begin. We'll start off with whatever we're provided with. So here we have y, which is given by ax squared. This is divided by the factors x minus a, x minus b times x minus c. Plus we have the second term, which is bx divided by x minus b multiplied to x minus c. So what we'll do, we'll combine the third and the fourth term. So here the common denominator will be x minus c, and in the numerator we have c plus x minus c. So here the positive c and the negative c gets cancelled out, and that leaves us with x in the numerator. Now what we'll do, we will combine the second and the third term. The first term remains the same. We have ax squared divided by x minus a times x minus b multiplied to x minus c. Plus, let's combine the second and the third term. So here we have the common denominator, which is x minus b times x minus c. So in the numerator we have bx plus, here in the second term, which will be x multiplied to x minus b. Right. So that means we will have, so bx plus x, and this will be, let me do it here, bx plus x squared minus bx. That means the first term and the third term gets cancelled out. That leaves us with only x squared. We can rewrite it as ax squared divided by x minus a times x minus b times x minus c, plus we have in the numerator only x squared. So we have x squared divided by x minus b times x minus c. Now what we'll do, we'll combine the first term and the second term, and that's going to give us y equals to, so we have the common denominator, which is given by x minus a multiplied to x minus b multiplied to x minus c. So in the numerator we have ax squared as the first term, and in the second term we have x squared multiplied to x minus a. So that means we have ax squared plus x cubed minus ax squared in the numerator, which will be divided by x minus a times x minus b times x minus c. So here ax squared and negative ax squared gets cancelled out, and our simplified form of y will now be x cubed divided by x minus a multiplied to x minus b times x minus c. So we're going to label this as equation number 2. So we started out with equation number 1. So that means this particular expression has been now simplified to give us y equals to x cubed divided by x minus a times x minus b over times x minus c. Now we'll take the natural logarithm on both sides. So we'll get natural log of y equals to natural log of x cubed divided by x minus a times x minus b multiplied to x minus c. So we are going to use three properties of logarithm. The first one being, if we have log of a over b, so this is the same as log of a minus log of b. Log of ab, so this will be equals to log of a plus log of b. And the third property being, if we have log of a raised to the power of b, then this will be equals to b times log of a. Right. Now we'll use this particular property and apply it to the right hand side of this expression, and this is going to give us log of y equals to 3 times natural log of x minus log of x minus a minus log of x minus b minus log of x minus c. Now what we'll do, we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of natural log of y, which will be equals to 3 times derivative with respect to x of log of x minus derivative with respect to x of log of x minus a minus derivative with respect to x of log of x minus b minus derivative with respect to x of log of x minus c. Fine. Now we are going to use the derivative of the logarithmic function, which says that if we have ddx of log x, that is given by 1 over x. Now for the first derivative, we have derivative with respect to x of log of y, so we will get 1 over y But here, since we have y instead of x, so we'll use the chain rule and multiply to derivative of y with respect to x, which will be equals to 3 times derivative of log x is 1 over x. So we have 3 over x minus 1 over, we have log of x minus a, so we'll have 1 over x minus a. But since we have x minus a instead of x, so we'll need to multiply it to derivative with respect to x of x minus a, which is obtained as a consequence of the chain rule. Similarly, for the third term, we are going to get 1 over x minus b multiplied to derivative with respect to x of x minus b minus 1 over x minus c multiplied to derivative with respect to x of x minus c. Right. So that's going to give us 1 over y times derivative of y with respect to x equals to 3 over x minus 1 over x minus a. So derivative of x minus a, that simply equals to 1, because derivative of x with respect to x, that's 1, and derivative of a being a constant, it will be 0. For the third term, we have 1 over x minus b minus, for the final term, we have 1 over x minus c. Now, what we'll do, we will do a little bit of manipulation here. We have 1 over y multiplied to derivative of y with respect to x. So what we'll do, we can split 3 over x into 3 parts as 1 over, that's the sum of 1 over x added to itself 3 times. So that means we have 1 over x minus 1 over x minus a. This will be added to 1 over x minus 1 over x minus b plus 1 over x minus 1 over x minus c. So here we have split 3 over x into 3, 1 over x's. That gives us 1 over y times derivative of y with respect to x equals to, so combining this is going to give us negative a divided by x times x minus a plus negative b divided by x times x minus b plus negative c divided by x times x minus c. We're going to multiply both sides with y, so this is going to give us dy over dx equals to y. Now we have 1 over x as the common factor in both the 3 terms, so we'll take 1 over x as the common factor, so this will get multiplied to, so here we have negative a over x minus a, or simply put, this will be a divided by a minus x. We have multiplied both the numerator and the denominator with negative 1. Similarly, for the second term, we have b over b minus x, and for the third term, we have c over c minus x, and this is exactly what we had to show, hence proved.